Assalamualaikum warahmatullahi wabarakatuh. Hello, I'm Afifah Thahirah from Mathematics Education 2020, Development Universitas Negeri Jakarta. In this video, we will try to evaluate the integral using the integration by parts method. Before we try to evaluate the integral using the integration by parts method, we need to know what is integration by parts. Integration by parts is another method that we can use to evaluate an integral. Integration by parts is a special technique of integration of two functions when they are multiplied. This method is also termed as partial integration, and this method is used to make complicated integrations easier. And here the general form of integration by parts. Integral of f of x times g prime of x dx is equal to f of x times g of x minus the integral of f prime of x times g of x dx. And next, what kind of conditions make us able to use integration by parts method? Conditions make us able to use integration by parts method if there are two functions multiplied by each other. Both functions have the same degree of rank or cannot be used as derivatives of the other. And to determine f of x, use LIATE principles, logarithmic, inverse, algebra, trigonometric, and exponents. For example, if there is a logarithmic function, then the logarithmic function is used as a f of x. If there is none, the inverse function becomes f of x, and so on. Now, we will try to evaluate the definite integral from 0 to pi of x cosine of x dx. When we immediately look at this integral, it's not obvious how just straight up take the antiderivative here and then evaluate that at pi and then subtract from that evaluate it at 0. So we are probably going to have to use a slightly more sophisticated technique. And in general, if we see a product of functions right over here, and if one of these functions is fairly straightforward to take the antiderivative of without making it more complicated, like cosine of x, and another of the functions like x, if you were to take its derivative, it gets simpler. In this case, it will just become 1. It's a pretty good sign that we should be using integration by parts. And like I said before, we want to find an f of x that when we take its derivative, it simplifies it, and we want to find a g prime of x that when we take its antiderivative, it doesn't get more complicated. So let's do that over here. Between x and cosine of x, which one gets more simple when we take its derivative? Well, the derivative of x is just 1, so we gotta make that our f of x, in which case, f prime of x is going to be equal to 1, and then what would our g prime of x be? Well, our g prime of x is equal to cosine of x. If we take its antiderivative, it doesn't more complicated. The antiderivative of cosine of x is sine of x, so our g of x is sine of x. And now, you could think about pluses and all of that, but remember, this is gonna be a definite integral, so all of those arbitrary constants are going to get cancelled out. So now, let's just apply the integration by parts here. Definite integral from 0 to pi of x cosine of x dx is equal to f of x times g of x, so that is f of x is x, g of x is sine of x, minus the integral f prime of x is just 1, times g of x is sine of x, dx. The integral of 1 times sine of x dx is equal to minus cosine of x, so we can write down minus cosine of x is subtracted from x sine of x. We can simplify become x sine of x plus cosine of x. Remember, this is a definite integral, so we are going to evaluate this whole thing at pi and at 0, and then take the difference between the two. So this is going to be equal to pi sine of pi plus cosine of pi, and then from that we're going to subtract this whole thing evaluated at 0, so it's going to be 0 times sine of 0 plus cosine of 0. So let's see, sine of pi is just 0, so this is just going to be 0. Cosine of pi is negative 1, and then 0 times sine of 0 is just 0. Cosine of 0, that is 1. So we have negative 1 minus 1 is equal to minus 2. And we are done. Okay, that's all from me. I hope this helped you guys understand how to use integration by parts. Hope you guys have an excellent day. Thanks and see you. Assalamualaikum warahmatullahi wabarakatuh.